So we can solve this bell work pretty quick. Two principles of equality will do it, which we've seen already. And remember, we're doing this with some purpose. So it's not, we're not just doing things randomly here. So the first thing I want is that plus 3 to go away. And by go away, I mean to make it a 0. So I'm going to subtract 3 from both sides here, because that is what a principle of equality is. Whatever you do to one side, you must do to the other side as well. So at this point, I can take that negative 4/5 x and I can drop it. And then that would equal, because 3 minus 3 is 0, so that's zeroed out just as we had planned it and forced it to do, but negative 25 minus 3 is negative 28. So now we have this equation, and one last principle of equality will solve this one. Last thing we want, though, is a 1x, not a negative 4/5 x. So a principle of equality, to change a value to a 1, is either multiplication or division. So I'm going to take that negative 4/5 and simply divide it by itself. That's a very easy way to get 1. Take something and divide it by itself. And, I just have to do it to the other side as well. Okay, so on the right side, though, okay, because I know negative 4/5 divided by negative 4/5 is 1. But in my calculator, when I put negative 28 divided by negative 4/5, I need to put the negative 4 divided by 5 in parentheses. Otherwise, the calculator, I think it'd give me 7/5. Which is not, it's not correct. But it is doing it by the order of operations. That's why it's giving you that incorrect answer. The parentheses will help the calculator know that you want to do the negative 4/5 as a fraction. But when I put this in the calculator, I get 30/5. So it's 35. Then I can go back up to the original equation. I take the x, I replace it with 35, and then I check for truthfulness. So in the calculator, I type in negative 4/5. I'm putting in parentheses again because I'm working with a fraction, times 35 plus 3, and I do get negative 25. This right here ends up being a true statement when we replace the x with 35. So now I know x equals 35 is actually the solution. That's what we wanted. So there's our two objectives. I can use distribution and combining like terms to simplify equations. And then I can use principles of equality to create zeros and ones to solve the equations, which we just did. We just created zeros and ones on the bell work. But now finally, we're going to start mixing this with 1.1, where we're going to need to use some distribution and combining like terms. That's going to simplify the equations into something that should be more noticeable, something a little bit more familiar, and then we can just use principles of equality after that. So what is the solution? A solution to an equation is a value that you can exchange the variable with in order to make the equation true. Just remember, not all equal signs are true statements, but the values we're finding will make the equal sign a true statement. So that's what we need to be able to solve for, but we can use principles of equality to solve for those. We can also use distribution and combining like terms to simplify to make the principles of equality possible, or at least a little bit easier. So remember, though, there are an infinite number of values that will make these false. We want only the true, the value that will make the equation true. Okay, then we've seen these slides several times. Remember, when we see these equations, we can work on them. We can force things to happen in those equations that we want to happen. And so we need to use these with purpose, right? So that's the addition and subtraction principles of equality. We use these two to make zeros. Now, why do we want to make zeros? It's because it's going to make those values go away, so we don't actually have to look at them anymore. That will be a way for us to simplify the equations too. But then we use multiplication and division principles of equality to make ones. Now, we saw this on the bell work, just like we've seen in the other classworks, is that we're using these with purpose. If we're going to make ones, we're doing it to the coefficient. So if we see that a coefficient is not 1, and usually this is towards the end of the problem, then we will force it to become a 1, usually with the division principles of equality, but we may use the multiplication principle of equality. So we saw both of these in the bell work, but again, we're going to add to this, and you'll have to do some distribution and combining like terms first, and then you can use these principles of equality. This is a basic process for solving equations. First thing you're going to do is distribute. Now, when you're distributing, or how do you know if you're going to distribute, is you're going to look for parentheses if you see parentheses, there we go. If you see parentheses in the problem, you need to know that you're going to have to do distribution, and it should occur first. Once you're finished with distribution, you're going to do combining like terms. Now, sometimes we may see examples that we don't need to combine like terms. That's okay too. In fact, we may see problems that don't need distribution. Just like we did on the bell work, it happens. But if we need to do these, it's distribution, then combine like terms. It needs to be in that order. Then we look to use principles of equality to force zeros so that we can ignore those values. We're going to do this with either addition or subtraction. This will help us to isolate the variable. The thing is now, with the principles of equality, especially to force zeros, and today's the first time we're going to see this, we will be doing this to x terms. Okay, so we're going to see terms that have x's, and we're going to zero those out so that it will simplify the equation and it will isolate the variable onto one side of the equal sign. That's what we mean by isolate the variable. We only want it on one side of the equal sign. The fourth one here is, and this is usually what we do last, is use a principle of equality. That's division or multiplication, which we use to create zeros, specifically with the coefficient. Now, keep in mind that this coefficient, it needs to be positive, because sometimes what happens is the student can get to the end here, they'll see negative x equals, let's say 8, and they'll say, hey, there's my answer right there. Now, if you checked, you'd find that whatever the equation is, this wouldn't work. It would give you a false statement. The reason that is because the coefficient of x is actually a negative one. It was a phantom one there. So you'd have to use the division principle of equality to force this to become a positive one. Just divide both sides by -1, and you'd be done. So just be aware of that. It's not such a common mistake, but it's a mistake that happens often enough that I feel like I should address it right here. So again, the point of that was, if you do not see the 1 there, it is there, and you do not want to end the problem with a negative variable like we see here. So here's our first example then. Let's go ahead and solve this one. And we see, again, and this is kind of what we're expecting with this lesson, parentheses. Well, we can work with parentheses, just if we see them, we are expecting some distribution. So I'll be distributing this 3 into the parentheses. We'll need to remember that distribution is multiplication. So when I say distribute, I'm taking the 3 and multiplying it by the first term, 5y's. This is 3 groups of 5y's, which would be 15y's. And then we also have 3 times -5, which would result in -15. Okay, so that simplifies that left side of the equal sign. Don't worry about combining the 90 with it because it's on the other side of the equal sign. If we start working with the 90 and -15, we have to do this with principles of equality. The other thing too here at this point is, do not combine the 15y with the -15. They're not like terms that you can combine them, so don't. So next, well, we should be expecting 2 more principles of equality to finish this. We got that -15. I want to just be able to take the 15y's and drop them. So to do that, I'm going to have to zero out the -15 by adding 15 to both sides. So this 15y now that we've dropped, the -15 zeros out, and 90 plus 15 is 105. So one last principle of equality will solve this one so that we end up with just 1y equaling something. And again, it's a division principle of equality. To make that 15 a 1, we'll have to divide it by itself. But if we do it to one side, we have to do it to both sides. So now in my calculator, I take 105 divided by 15, enter, and I get 7. Now the last thing I'm going to do here is just say, well, is 7 actually the answer? Well, I'm going to take the y, I'm going to replace it with 7, and I'm going to see if that gives me a true statement. So in my calculator, 3 parentheses, 5 times 7, minus 5, close parentheses. I push enter, I see 90, it gave us a true statement. And now I know for sure that if you were to replace y with 7, you do get a true statement. That's my solution. So I'm going to keep that as a 1y. Some students prefer to make that a phantom 1. And if you do, that's fine, since you're doing it by hand. On the assignment, you won't have to do that. But I'm going to keep the 1 there, just so we know what we're actually trying to force to happen there. This next one, we do have the fraction right there. Please don't let the fractions intimidate you. I say that because fractions can destroy lives, but we are distributing this 1/2 into the parentheses, okay? And again, distribution is multiplication. So that means I'd have to take the 1/2 first and multiply it by 8b. Just remember, if you put this in the calculator, put parentheses around your fractions like this, okay? Now, some of you may not need it. You know it's just half of an 8b's, which would be 4b's. So the calculator is going to give you the same answer. And then also we have 1/2 times that, that'd be positive 20. But again, in the calculator, we're going to put this in parentheses. 1/2 times 20 is positive 10. Since it's positive, I'm going to show a plus sign between the 4b and the 10. And now I can take that 50 equals and drop it, and this gives me the new equation. So here's something else to think about is if we were to take this equation, let's say that we had started with this equation, you would have been like, hey, that's pretty cool, I can do that one. 2 principles of equality and we're done, and that's true. But we had to start with that first part. So it's not like it's harder work, it's just more work because we let the calculator do that for us. So proceeding here, now 2 principles of equality, like I said, this will solve the equation. So I got that plus 10 with my 4b's. I'm going to zero that out by subtracting 10 from both sides. On the left then, I've got 50 minus 10, which is 40. Then the 4b I can drop. And then 10 minus 10, it's zeroed out exactly like I wanted to happen. I forced that to happen. And then I can take my 4b's and simplify that into 1b's by taking that 4 coefficient in red and dividing it by itself, 4. But if I do it to one side, I need to make sure to do it to both sides. So 40 divided by 4 is 10. This should be my solution, but I'm going to go back up to the top. I'm going to say, well, I think B right now should be 10. I'm going to check for truthfulness. So on my calculator, I type in 1/2, parentheses, 8 times 10 plus 20, and I push enter, and I get 50, which is what I was expecting. I was expecting that because just looking at my work, it looks like everything looks good. And I can proceed from there. But again, that was because we found that if you replace the b with 10, the equal sign is a true statement. So for this one, we now see some distribution. We also see some other stuff with the distribution. So here's a mistake we don't want you to make. So we are going to distribute the 10 to the 4x and the negative 5. We do not want you to distribute to the 6x because distribution is multiplication, and we do not distribute where there is a plus sign between this is a term and then this next term. So don't just distribute everywhere. It only goes into the parentheses. So in working with this then, I've got 10 groups of 4x's. So 10 times 4x's, that'd be 40x's. But then I've got 10 groups of, I'm saying that's negative 5 because of the minus sign, right? So 10 times negative 5 is negative 50. You can see that that comes out for me as minus 50 in this equation. And then I can just take the rest of that equation and just drop it because there was no other distribution that was needed. We will see some problems that have double distribution or two sets of distribution, not this one. So now that I've done that, like I said, once we distribute, we should be looking to combine like terms. On those last 2 examples, we didn't see any, so we went into principles of equality. But this one I do see some. I see, first off, that I can take my 40x's and combine them with my 6x's. That will tell me some number of x's that I have. So that'd be 40 plus 6, which is 46x's. Now those are my x terms. I also see a negative 50 and a negative 2 constants. So that would show as negative 50 minus 2, which is negative 52. And then I can drop the 40. So another mistake that we see at this point is where students combine the negative 50, the negative 2, and the 40. You cannot combine terms across the equal sign unless you're using principles of equality. And that's actually where I'm at. Now again, just to relate this to what we've seen, if you had started with this equation right here, you probably would have solved that with ease. But we see again the need for distribution and combining like terms, which just takes us back to 1.1. It's the stuff we've already seen. It's stuff we should be pretty familiar with and be able to do, even if it's in an equation like this. But now that we've done that, we have this 2-step equation that we can solve, and that's what I'm going to do. I'm going to get rid of that negative 52 in green by adding 52 to both sides. And yes, I do need to do it to both sides because it is a principle of equality. So this allows me to take the 46x and drop it. Negative 52 plus 52 is actually 0, and then 40 plus 52 on the right side would be 92, the right side of the equal sign. Last thing I need is, I don't want 46 x's. The last thing I need is a 1x. So I can make a 46 become a 1. Yeah, no problem. All I've got to do is take it and divide it by itself. So 46 divided by 46 is 1. But I got to do it the right side as well. 92 divided by 46 is 2. So I've got to go back up to the top of the equation, right? The first equation that we started with. And I've got to replace not just 1x with 2, but there's 2 x's in that set, right? So I'm going to check here for truthfulness. Okay, so on my calculator, 10 parentheses, 4 times 2 minus 5, close parentheses, plus, and here's the other x, 6 times 2, right? We're replacing the x with 2, minus 2. I push enter, and I get 40. So when I replace the x's with 2, I do, just as planned, I get a true statement. So since it is true, I can take this solution down here and box it in, because I know that it made the equation true. It is the solution. Well, here's another one. Now, this one I kind of highlight because this is one where students make a lot of mistakes. Well, not a lot of mistakes, just there's one big mistake that happens here. So in looking at this problem, some students, they won't even show the distribution. They'll just say, this is going to be negative 7x plus 2. But this is incorrect. I'm showing this because it is incorrect, but it's a very common mistake that students make. And it's because really they're not really thinking about the distribution, which should occur. Part of this is correct, and we'll see that when we actually show the work. The thing about this problem, at least at this point, is there are parentheses, so we are expecting distribution. What are we distributing? It's actually a negative 1. So don't just apply the negative to the first term. It needs to actually be applied to both terms right there. So really what we end up with is one group of 7x's, which is, well, negative 7x's. But then, in addition to that, we also have the negative 1 times the positive 2, which is negative 2. Okay, so that's the distribution. Again, part of that was correct. It was the negative 7x was the correct part. But you see, it's something so minor as just the addition sign should be a subtraction sign. But if you have the addition sign there, you're likely to end up with the incorrect answer. Although some students in the past, they've done it, but they've done it incorrectly going through it, and so they end up with the correct answer. Just be careful. But now that we've done all the distribution that we could possibly do there, now I look for any like terms that I can combine. And I see a constant of 5 and negative 2, which would just be really 5 minus 2, that's 3. But also I see a 3x and a negative 7x's. So how many x's will this be? It's 3 minus 7. You can put that in the calculator, you get negative 4x's. So my new equation then shows 11 equals 3 minus 4x. And yeah, we're now at the point where we can use two principles of equality to finish this off. So that is what I will do. So the first thing I want is that 3 to go away, meaning I want it to be 0. So I'm going to subtract 3 from both sides. And I got a negative 11 minus 3, which is negative 14. That's going to equal 3 minus 3, which we zeroed out, which we planned and have done on purpose. Here's another mistake we see on problems like this one. Students drop a 4x. It's not 4x. It's a, don't forget the negative there. It's a negative 4x. Okay, because if you drop that as positive 4x, you're going to end up with the opposite of the answer we end up with. And if you check it, it would give you the false statement there at the top. So we're at the end. One final principle of equality should do it, and then we'll check. So that 4x, I want to become a 1x, so I will force it to be 1x by dividing it by itself, which is negative 4. So negative 14, I will also divide by negative 4. So let's see what we get. Negative 14 divided by 4. My calculator is showing me 3.5, and that's okay. Some students like that decimal right there. I actually don't mind this decimal either because it's pretty. It ends and it terminates. It looks good. But some students like to show this as a fraction, which you can. Remember, on the calculator, you're gonna push the math button. It's 3 buttons down from the top left, and then you're gonna just push enter, enter, and it would show you that then your x. So yeah, math, enter, enter. I got 7/2. Now either one of these should work. I'm going to use the decimal just because it's pretty easy to type in. when I check this. So I'm going to take the x, replace it with 3.5. But both x's, you have to replace all the x's with that same exact value. And at this point, yep, I'm checking for truthfulness. Now, when I type this in and I push enter, I should expect to see 11, negative 11, right? So 5 plus 3 times 3.5 minus parentheses 7 times 3.5, and then plus 2, close parentheses, enter. I do get negative 11 right there. So I can see here that I do have the solution to the equation. Either one of these work. Remember, they're the same exact solution. They're just shown in different formats. One's a decimal, one's a fraction. So be careful, because in checking my work with one of the other classes, I typed the equation in incorrectly, and it showed me negative 18. And so you got to be careful about that. Make sure you're typing these in correctly into the calculator, so that when you get this, when you push enter, you do see the correct answer. Now, if you see that it's incorrect and you try it again, maybe it's still incorrect, you have to go back and check your work. Here, everything looks good, so we're just going to keep it that way. So this one, it's a little different here. And what I'm seeing at this point is I do need a principle of equality. And the reason I know that is because there's no combining like terms on the left or the right, and there's no parentheses, so I know there's no distribution either. Maybe I should have did that in the other order. There's no distribution, then there's no combining like terms. So I am expecting to jump straight into principles of equality here. But what you may find that's different about this problem is that there's x's on both sides of the equal sign. That's new to us for this class. But remember, we can use principles of equality to force even x terms to become zeros. So here's what I do is I say, just from the beginning here, I'm going to put my x terms, I would just like my x terms to be on the left, and then I would like my constants, I'm going to use I know people today say that's a hashtag, but it's a number symbol for my generation. So here's what I'm going to do. I'm going to analyze this just based on what I just did there. I want x's on the left, constants on the right. So I start with my first term, negative 3x. It has an x term. It's on the x side of things. That's okay. Checks off. It is where it should be. What I don't want is this negative 14 on the x side of things, because it's not an x term. It's a constant, negative 14. So right off the bat there, I see that I need to zero out that negative 14 by adding 14. But it is a principle of equality, so I need to do it to both sides. Now on the right side, you'll see that I put this beneath the negative 2. I would not want to put it beneath the negative 7x, because I'm not combining it with the negative 7x. The negative 7x is an x term. 14 is a constant. I need to combine that with another constant on the right side. So here's what happens is my negative 3x, I take it and I drop it. Just as usual, I have the negative 14 plus 14, which zeroes out. And that was part of the plan there, because it was a constant on the x side of things. That's no good. The negative 7x I will also drop, because I didn't combine it with anything. And then I have negative 2 plus 14, which I just put in the calculator, and it gives me positive 12 now. So this is my new equation, but again, even this equation looks different. What I mean by that is, if you had started with just this equation, you may have been like, what the crap do I do? Well, we just did the one step. We can work with this one as well. And it's the same idea. Here I just want, so the negative 3x, it's on the x side of things. That's good. The negative 7x, though, is on the constants, the number side of things. That's no good. So I need to zero it out. And yes, I'm not addressing the 12, because I'm just doing this one term at a time. So the negative 7x there, it needs to go away. It needs to become a 0. How do you make a negative 7x a 0? Just add it to itself. The same way you would with constants, but now it has an x with it. But yes, if you do it to one side, please do it to the other side as well. So negative 3x's plus 7x's would be positive 4x's. In the calculator, you would just type in negative 3 plus 7. Negative 7x's plus 7x's, that zeroes out just as we planned and we wanted to happen. So it did exactly what we wanted, and then the 12 can be dropped. Now this equation should look more familiar, because I need only one last principle of equality to solve this, to make my coefficient a 1. And I'll do that by taking the 4 coefficient and dividing it by itself, because anything divided by itself is 1. Then on the right side, 12 divided by 4 is 3. So in checking this, I've got to check it twice in the calculator. The first I'm going to do on the left, I'm replacing the x with 3, but both x's with 3. But again, I'm just going to do this one at a time. On the left side, I've got negative 3 times 3 minus 14. Enter. And on the left side of the equal sign, I get this negative 23. So I am checking for truthfulness. On the right side, I've got negative 7 times 3 minus 2. Enter. And on the right side, I also get negative 23. Negative 23 does equal negative 23. This is a true statement, which means I now know that I have, in fact, found the solution. But again, the thing that may differ from what we did in 7th and 8th grade is I'm using the calculator to check this. I'm not actually even showing the work for it other than to just up here replace the x's with 3's and just check for truthfulness. Let's go on to this one then. Okay, for this one, I do see 2 sets of parentheses, so I am expecting 2 distributions. And what I also noticed from, just like we saw 2 problems ago, is I'm going to be distributing in this set of parentheses a negative 1. And in fact, I'll even show that 1x. So it's negative 1 times 1x's, which would be negative 1x's. And then also negative 1 groups of positive 3 would be negative 3. So that is that distribution. I also have the 7 to distribute into this set of parentheses. So that'd be 7 groups of 2x's, which is 14x's. And then also 7 groups of, again, that's a negative 2, which would be negative 14. Now the rest of this just drops, right? The 5 I can just drop. And also the equal sign stays in the same position. Okay, so that takes care of the distribution. Like that's the process. Distribute, now look to combine like terms, no problem. I see that there are like terms, the 5 and the negative 3, which again, you just show us 5 minus 3, which is positive 2. And then my negative 1x. There were no other like terms with this negative 1x to combine, so I'm going to keep it there. And now I need to show the 2 is positive with a plus sign. Now again, at this point, I'm just taking a little detour, but don't forget, you cannot combine this negative 1x with this 14x's at this point. You can't just combine them directly. You have to use principles of equality when combining like terms across the equal sign. Now the rest of this, though, the 14x minus 14, it drops. There were no like terms to combine on the right side. So this is my new equation. Still, it shouldn't be a problem. This one now is going to proceed exactly like the one we just barely did. So I'm going to identify. I want my x's on the left side, and then I will put my constants on the right side of that equal sign line. So then I look at each term. On the left side of this equal sign, I've got a negative 1x. Okay, that's an x term, so that's okay. The positive 2 is not an x term, so it has to, I need to zero that out by subtracting 2. But yes, if I do it one side, I need to do it the other side. So the negative 1x here is going to drop. 2 minus 2, as planned, that became a 0, so I can ignore it. And then the 14x drops as well. And then also negative 14 minus 2 would be, I almost forgot my x, but negative 14 minus 2 is negative 16. We're almost there. 2 more principles of equality will do this. So once again, I see I've got the 14x's, but it's on the number side of things. I don't want x terms with my numbers side. So I need to zero out that 14x by subtracting 14x's on both sides. Okay, so on the left, negative 1x's minus 14x's would be negative 15x's. And this should equal 14x's minus 14x's. That zeroes out as we had planned. And again, this term right here is a negative 16. It needs to drop as negative 16. Don't forget that negative sign. And then, last of all here is I want this coefficient to become a 1. I got 1x equals, and then I got, well, just make that a 1, right, by dividing both sides by negative 15. So negative 16 divided by negative 15. Let's see what the calculator gives us. Negative 16 divided by 15. Enter. So I got 1.06 repeating, and I hate that fraction, that decimal, because it looks like garbage. So I'm going to change that to a fraction by just pushing math enter, enter, and that will change it into a fraction for me. So that's 16/15. All right, now the last thing, just like we've been doing, I'm going to take the x's, replace them. I'm going to use the fractions because the decimal sucks. But 16/15, but for both x's, right? So on the left side, I've got 5 minus parentheses and then in parentheses 16/15. Close parentheses plus 3, close parentheses, enter, and I got, let's see, I think I typed that in. I got 0.93 repeating. Let's see what we get on the right side. 7 parentheses, 2 parentheses, 16/15, close parentheses, minus 2, close parentheses, enter. Yep, I got the same thing on the right side, 0.93 repeating, which is a true statement, right? So that ended up being true. And now I know that I have actually found the solution. Either one of these would work, but I like the fraction better. Okay. There's our objective. I can use distribution and combining like terms to simplify equations, which we've seen a lot of today. And then also we can use principles of equality to create zeros and ones to solve the equations.